We're going to be calculating the volume of a frustum cone. So first question, what is a frustum cone? Let's say we have a cone like this, and we chop off the end. So we chop off that pointy end. The remaining portion is our frustum cone. So it's going to look something like this. So this is what a frustum cone looks like. We have several parameters here that we can work with. We have big R, which is the radius of the cross-section at the very top. We have little r, which is the radius of the cross-section at the bottom. So from looking at this, big R is greater than little r. And we also have h, that's the height of our frustum cone. So how do we start here? We can't immediately use any triangles. We can't directly calculate one of the circles, but we can start off with the original cone. So let's go back here. So if we go back to the original cone before we chopped off the end, we have to look at now the height of the entire cone. So we have this extra height, which is the length of the cone that we chopped off, little h. So to get the volume of this cone, this would be calculated as V equals pi r squared h plus big H divided by 3. So this is your standard calculation for the volume of a cone. It'd be pi r squared times your height. In this case, I'm splitting it up into h plus little h divided by 3. Now, the second thing that we can calculate is the volume of the small cone. This is the tiny cone that we've chopped off. So I'm going to call this V tiny, and we can calculate this as pi r squared little h over 3. So the radius of the cone here is little r. So then, to get the volume of the frustum, we're going to take V minus V tiny. So let's start solving for that. Here we can start with V frustum equals pi r squared little h plus big H divided by 3 minus pi little r squared little h over 3. Now let's expand this out. Okay, now we have a problem here. We're given big R, little r, and big H, but we're not given little h. We're not given this value. So we need to eliminate that from our equation. So to do that, let's have another look at the big cone. We have essentially two triangles. We have triangle 1 in blue, and we have triangle 2 in red. And what do we notice about these two triangles? These are similar triangles because they share this angle, they share this angle, so they must share this angle. So knowing that those angles are the same, we can do a little bit of algebra and we can eliminate little h from our equation. So first, let's, for example, take tangent theta. Let's call this angle theta at the bottom. Tangent is opposite over adjacent. So for the little triangle, tan theta equals r over h. But because that angle is the same for the small triangle and the big triangle, tan theta is also equal to big R over big H plus small h. Now we have this equation that's going to help us get rid of our unknown variables. So using our tan theta equations, let's solve for little h. Let's do some rearranging. So I'm going to multiply and divide by some things on each side. First, let's multiply by big H plus little h on both sides and divide by little r. So we're going to get big H plus little h over little h equals big R over little r. I can split this up into big H over little h plus 1 equals r over little r. Move that 1 over. Then I'm going to multiply both sides by little r, make it a little bit easier here. I'm going to multiply by h, little h on both sides. I get this. Now I have something I can plug in up here. So let's do that. Actually, I'm just going to go down here a little bit, get a little bit more room. Rewrite it. We have pi r squared little h, pi r squared big H, pi r squared h 3. Okay, let's go do some algebra. This just stays pi r squared, and now we're going to plug in our hr over big R minus little r times 3. This stays the same, and we plug it in here. To make things a little bit easier, I am going to factor out pi over 3. It's going to leave us with, I can also factor out a big H. So now I have r squared, now I have r squared little r over big R minus little r plus r squared minus little r cubed over big R minus little r. Next thing I'm going to do is I'm going to actually factor out that big R minus little r on the bottom. So I'm going to move that out of the brackets. So this will just be r squared little r. Now I'm going to have r squared big R minus little r minus r cubed. So now we can do some more simplifying. Expand that out. Big R cubed minus r squared minus r squared times little r minus little r cubed. And so these two terms cancel, those disappear. And now we are left with pi times h r cubed minus little r cubed over 3 big R minus little r. And the last step is that we can actually factor this out a little bit farther into this. This is just a little bit nicer because now let's just complete it here. You see that we have another term that cancels. So now, final equation for solving for the volume of a Frustum cone, pi h over 3 times r squared plus big R times little r plus little r squared. So this is the volume of a Frustum cone.